Good morning, guys. What's going on? It's Mr. Hanson at Mr. Hanson 404, and today we're doing a geometry video. We are continuing our triangle congruence. Today we have AAS, angle, side. So let's get right to it. So angle, side, triangle congruence tells you that two triangles, if you have two angles and a non-included side of one triangle, if those are congruent to the corresponding angles in another side of another triangle, then the triangles are congruent. So we've done several of these, and now we're on the next one. So skip through these. All right. Explain one. So justifying angle, side congruence. There is the theorem. Again, guys, if you have not yet got nice notes on this section, you need to, because it's going to make your life a whole lot easier. Two-column proof. We're trying to prove that this theorem holds. It's valid. So we're given that angle A and angle D are congruent. Angle C and angle F are congruent. You see how they're marked? That shows you that they're congruent. And side BC is line segment BC is congruent to line segment EF. So let's use that to prove that this is valid. So the angles add up to 180. That is the triangle sum theorem. So you're working to figure out what the angle could be. So you subtract angle A and angle C. And over here you got measure of D plus E plus F. Again, triangle sum theorem. So on these ones, it's kind of just like filling in the blank. So figure out what you have, figure out what you don't, and go from there. Measure of angle E equals 180 minus the measure of angle D minus the measure of angle F. So we're looking at the different triangles, right? So equivalent to these two are equivalent, these two are equivalent. That is the definition of congruent angles, because if the angles are congruent, they have to have the same measure. The measure of angle E is equal to 180 minus A, the measure of A minus C, and that's just substitution. Transitive property of equality tells you that the measure of E is equal to the measure of B. So we're saying that those two are congruent, and that again is the definition of congruent angles. And that is a way to prove it. Two column. So if you know the measures of the two angles in a triangle and the length of a side that's not included, does this describe a unique triangle? And this is where you're going to start finding the patterns and what these actually mean on diagrams. Yeah, because the side angles, the same side and angles must be known to be congruent to prove that two triangles congruent must be given to describe unique. So you have to have the two angles in the included side. If it's ASA, you have to have the two sides in the included angle. If it's SAS, each one looks a little different and how the information looks for you. Alright, what do we got next? No, we don't care about that. This is a good one. Could the congruence theorem be used in the proof? You cannot use a theorem to prove the theorem. It's like when people ask you for a definition of a word and you use the definition of that word. It doesn't work. Alright, so using angle, side. This is a flowchart proof. And this type of diagram here, you're going to start seeing a little more often. So we're given and we're given. So lines M and N are parallel. Line segments AC are congruent. So AC is congruent to EC. So I'm going to show that. Prove that the triangles are congruent. So let's figure out what they did here. And again, if you don't like flowchart proofs, do whatever. Like proving historically has been very you need to do it a certain way, whereas in my mind, just do it. It don't matter how you do it. Nike. Now send me a check, Nike, so I can get more of these. These things are mad comfortable. Alright, so we're given that the line segments are congruent. So we're trying to show that the triangles are congruent using the angle, side congruency theorem. And again, I'm going to tell you right now, I really don't like this style of proof. It's just not how my brain works. Now, over here, we're also given something. We're given that they're parallel. So going back to our angles, right, you know that measure of angle E and measure of angle A are going to be congruent because they're alternate interior angles. And then same logic applies on angle B and angle D. So that, you see everything that we've kind of been learning is starting to build on each other. So if you take a look now, you have angle, angle, side. Angle, angle, side. What are we using? Angle, angle, side. So because of that, this theorem holds. This is different than ASA because with ASA you had to have the two angles but the side that's included in between them, whereas now it's any non-included side. Alright, so here's a chance for you if you want to give us a shot, and I'll do my best. So what are we given? 3 givens. So we know that this is parallel to this, we know that this is parallel to that, and that is congruent to that. Okay. So the parallels are important because that tells you how to use the angles, right? So you may need to take a little bit and go back and study that up real quick. I know you guys took lots of definitions. So we have the different givens. So I'm just going to start plotting these. So the line segments being congruent, the lines segments being parallel, the line segments being parallel. Oop. All right. Corresponding angles theorem is our friend today. Corresponding. So we have angle ACB. Angle ACB. Different color. Is congruent to CED. Right? Corresponding angles. We have. So let me put that here. ACB congruent to CED. You might want to listen to me more than you read from me, right? We also have CAB, cab. Cabs are here. And ECD. See, I'm been a little pressed on getting these videos done, so I'm not going to be editing these my normal way, but dropping some gems, you know. Go back maybe. If you know what cabs are here, then I rock with you. So AAS, right? Congruency theorem. We have the angle, and the side. The angle, and the side. And their corresponding parts are congruent to each other, therefore the triangles are congruent. Bam. Your turn. I'm going to let you rock with that. Make sure you're using the parallels. I can tell you that this will be congruent. It says write a paragraph proof, write whatever you want. Don't let nobody box you in. Alright, applying it. So you have some triangle. I really don't like these problems because you're never going to see somebody. I mean, never say never, right? But who sells triangular plots of land? Get out of here. Alright, anyways, so what do we have? What do we know? We know that this angle is congruent to that angle. So 1 and 2, right? Now, you could determine if these are congruent just by looking at the 1, 2, 3, 4, 1, 2. So you know that these are congruent. But they want you, so you know these, right? Now you could see right there, what could I use right there? Do you see it? Angle, side, angle, ASA. I could do ASA, but they are trying to get you to use AAS. So you would need to know what this angle is, and this angle is in blue. What they want you to do is use the distance formula to calculate the distance, right? We've done this a million times, so you plug it in. This is a good review, and again, it's crazy how everything's coming back together, right? So you could use AAS to prove that, but I personally would have just done ASA right away because it's there. Alright, I'm going to let you do these. I have no interest in showing this today because I'm not trying to review distance formula, but if you don't remember it, go back and find my video on distance formula. Alright, again, these ones require distance formula, but I can tell you that this is going to work with AAS, and this is also going to work with AAS, so they're giving you ones that work pretty easily. Do I want to talk about this one? Yeah. 2 isosceles triangles share a side. With which diagram can the AAS theorem be used? So again, you don't have to go in and be like, oh, I need AAS or I need ASA. Like, use your tools. But you would want to use this one because this shared side is the non-included side. So you want to have the angle side, not angle side angle, to use ASA. When do you use the AAS triangle congruence theorem? Use it to prove two triangles are congruent by using 3 pairs of congruent corresponding parts. All of the different theorems use 3 pairs. You need 2 pairs of corresponding angles and 1 pair of non-included sides. Right? That's it. I don't got much else to say. So homework, definitely get used to identifying AAS. It's easy to get confused. So to get these ones and be like, these are all what AAS triangles could look like. Practice, pulling back your old angle theorem stuff as well as your distance formula, whatever else, is coming up. So, angle, side, we got one more. I know I might do it today, but honestly, I might low-key not. So, that is what it is. Thanks for watching. At Mr. Answer 4, hit that like button. See y'all later.